Wait. Here we go. In Chapter 5, we're going to be looking at three main types of compounds. We're going to be looking at what are called acids and bases. That's two types of compounds, but they're opposites of each other, so we'll put them on one line. That does mean, folks, dead serious, during the labs, be uber careful. Don't be accidentally touching compounds and then scratching your eyes. Okay? You could do permanent damage. Also, a lot of the stuff that we're going to be looking at will stain clothing, so you want to make sure you apron up, and you want to make sure you eye protection up, and then you really, really want to make sure you wash your hands very carefully after the fact. The second type of compound we're going to be looking at in this unit are what are called salts. Not just table salts, but salts in general. And then the third type that we're going to be looking at are what are called organic compounds. Organic means from life. Yep. You got to go. Yep. So those of you that got to go, go. Football players. So we're going to be looking at acids and bases. We're going to be spending a few days looking at acids and bases. Spending one day looking at salts and then looking at organic compounds. So first of all, acids and bases. Hey folks, what's an acid? You've heard the word. What does an acid do? Pardon me? You're right. No, you made a good comment. I heard it back there.
It's corrosive.
Yeah.
Corrosive material.
Okay. Some acids are corrosive. What we're going to be doing is we're going to be trying to label or quantify how strong acids are. We have a fancy word for that. We call it their pH level. It stands for power of hydrogen. Acids and bases. Bases are the opposite of acids. So let's talk about this. So there are other ways to classify compounds. The main way we classified compounds last unit was how they bonded. We talked about ionic bonds, and we talked about covalent bonds. And that works great. But there's another way, and that is by acidity. Now, Hayden is right. Very strong acids can burn you. We're not going to get out the uber strong stuff. I don't want you to accidentally drop something onto your skin and have it burn a hole through your skin. Actually, all of you are fairly familiar with basic acids because we find weak acids very tasty. They're in lots of our foods. Acids release H+ ions. Oh, hang on. Let's read that like a chemist would. They wouldn't say the letter capital H. What does the capital letter H stand for on our periodic table? What does the capital letter H stand for? Hydrogen. What does the plus stand for? Okay, it's a hydrogen plus ion. So normally hydrogen has one proton and one electron. When you put acids in water, they release hydrogen missing an electron. What does that electron want to do? Sorry, what does that hydrogen want to do? What does that ion want to do? It wants to gain an electron. How? Sarah pointed it out. Even to the point of burning your skin, ripping the electrons off of your skin molecules, if it can. Right? Weaker acids are part of some foods. Orange juice is an acid. Soft drinks, Coca-Cola is acidic. Lemon juice. And in fact, you're not going to taste acids because you shouldn't in this particular labs. You never taste them. But weak acids taste sour, and we like that in limitations. Stomach acid is another acid. You may have occasionally had some stomach acid come up, and you've gone, oh man, my throat is burning, disgusting. Stomach acid is actually HCl, and we use these to digest food. Your stomach is very acidic. Your stomach has hydrochloric acid, HCl. The acid in your stomach, if we were to somehow syringe it out, that would burn you quite dramatically. You'll see a bit later on when we look at our pH scale chart. Stomach acid is way off to the left, which means it's very, very strong. We also have acid rain, and that will dissolve buildings. Specifically, buildings made out of rock materials like concrete, like cement, like brick. Brick is the classic one. We can also use them for good stuff. Acids are able to remove rust. That's why if you drop a penny into a can of Coke or a glass of Coca-Cola and leave it there overnight, it'll look all shiny. And purify metals due to their corrosive, let me make that word a bit bigger so you can see it. Corrosive. In fact, most jewelry that you're wearing, I almost guarantee that it took an acid bath at least once somewhere along the way before you got it. Okay? So we have acids and then their opposite, their counterpart. You can think of acids as the dark side of the force, bases as the light side of the force. Their counterpart are bases. We have acids and we have bases. Bases feel slippery. Bases are used in bleach. Bleach is a basic solution. Oven cleaner is very basic. And now going back to what Sarah and Hayden said, and they said acids are corrosive. Bases are corrosive as well, but they're corrosive for a slightly different reason. What else is basic? Here's your hint. It's slippery and you use it in the shower. Soap is basic. Soap is a base. One of the things that bases do quite well is they bond with grease. That's why soap cleans you so well. Some foods are basic. Eggs are basic. Baking soda is used as a baking ingredient to neutralize acidic ingredients in baking. Some drugs, the local anesthetic, if you go to your dentist and before they give you the shot, they smear a bit of local anesthetic on the inside of your mouth to numb your mouth before they stick the needle in. That, I believe, is a basic solution. So we have something called the pH scale. And it's used to measure the acidity or the spell it right, Mr. Duick. Alkalinity, and you can draw an arrow how basic a substance is. The pH scale measures how acid or alkaline a substance is. Alkalinity is how basic something is. So here's a chart. Let's see if we can read this chart. You will get a chart like this, maybe this actual chart on your test as a handout on the provincial. Where's neutral? Middle, what value is that? There's a number right in the middle. 7. 7. The pH scale goes from 0 to 14. Why though? A long, complicated explanation, but it goes from 0 to 14. Neutral is in the middle. What element, what compound, not element, what compound is neutral? Water. So when they set up the pH scale, they said, you know what? Let's have water be dead center, neutral. And then if things are more basic than water, they'll be to the right. They'll have a bigger pH. If things are more acid than water, they'll be to the left. They'll have a lower pH. So, I told you stomach acid was way to the left. What's the pH of stomach acid? 1. What's the pH of tomatoes? 4. And you can see over to the left there, just to the left of water, there are lots of foods that we like. Although, too much lemon doesn't taste that great. We like a little bit of sour, a little bit of lemon. Grapes and wine, too much, a little too strong. Tomatoes, bananas, milk, water, eggs, baking soda, soap, ammonia, bleach, oven cleaner. Sarah, going back to your comment where you said that they burn, they're corrosive, it's not whether they're acidic or basic that they burn you. It's how far away they are from the middle value of 7. That's what'll do some damage, because you don't want to put oven cleaner on your hands either. Okay? So here is the pH scale. It goes from 0 to 14. Less than 7 is acid. Come on, pen. That I won't come. Let's try that again. Less than 7 is acidic. 7 is neutral. Greater than 7 is basic. Do you have to memorize that? I believe we will give you this terminology, but if you're having to look at this to say, it's worth knowing that to the right, more basic, to the left, more acidic. Using the pH scale. So the pH scale allows us to express a wide range of measurements using a nice small scale, just between 0 and 14. So 0 is, what do you think I want to write there based on what you've seen of this picture, the pH scale? What would 0 be?
Acidic.
Most acidic, yeah? $14 is what? Least acidic, we'll say it this way. It's least acidic, which means most basic or alkaline. But this is a bit of a weird table. The scale on this table matters. A change of just 1 on the pH scale represents actually a 10 times increase or decrease in acidity. Say what? Well, I'll show you. Okay. Now remember, to the left, Justice is more acid, so smaller is more acid. And again, do you have to memorize that, Hannah? No, but because you can kind of figure it out. Oh yeah, that way is acid, but it's nice to know. So, a solution with a pH 3 is how many times more acidic than a solution with a pH of 4? What is 4 take away 3? It's actually 10 to the 1, or 10 times more acidic. It's what's called a logarithmic power of 10 scale. So a solution, suppose you know its pH level is 2, and you want to know how many times more acidic is it than a solution with a pH value of 5. What's 5 take away 2? It's going to be 10 to the 3rd power, or 1,000, a 1 with 3 zeros. It's actually 1,000 times more acidic, which makes a huge difference. A solution with a pH of 3 is how many times more acidic than a solution with a pH of 7? Not 4 times. No. What?
Oh.
10 to the 4th. That's hugely important. It's 1, 2, 3, 4. It's 10,000 times more acidic. 1 with 4 zeros. Not 4 times more acidic. 10,000 times more. Like, way more acidic. How many times more acid are tomatoes than milk? So look at the chart. What's the pH value for milk? 6. What's the pH value for tomatoes? What's 6 take away 4? 10 to the 2. Or 100. 2 zeros. See how we're getting this? At least, Josh, it's a nice 10 times table logarithmic scale. If you're going to pick a times table, aside from 0 and 1, 10 is the easiest times table to work with. How many times more acid are grapes than bleach? Let's see. Grapes. Oh, Kenzie, you owe me an after-school detention. 6 minutes, apparently, just popped up on my screen. Grapes is a 3. Bleach is a 12. Now, the answer is not 9, though. You go 12, take away 3. The answer is going to be 10 to the 9th, or a 1 with 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros. That's 1,000 mil, a billion times more acidic. How many times more basic is oven cleaner than ammonia? Let's see. Oven cleaner, 13. Ammonia is 12. 10 squared, or 100. So it's a power of 10 logarithmic scale. Is that okay, Amy? Yeah? By the way, pH stands for power of hydrogen. The P is always lowercase and the H is always uppercase. Well, Mr. Dewick, how do we figure out if something is acid or basic if we're not allowed to taste it because it could be poisonous? We know they taste sour if they're acidic. Or if we're not allowed to touch it because it could burn our skin. We know that basics are slippery. We have something called pH indicators. And these are chemicals that change color depending on the pH of the solution that they're put into. There are a whole bunch, but these are 6 of the most common ones. 6 of the most common ones. The first one we call methyl orange. And you can see if you put it in water, what color is methyl orange right in the middle here? Yellowish, orangish. As you get more acid, what color does methyl orange change into? Red. So if you put methyl orange and you added it to some mystery liquid and it changed red, you would know this is acidic. There's also something called methyl red. It changes color a little bit sooner than methyl orange does. So it's also kind of orangey reddish in liquid. But if you put it in an acid base, in an acid bath, in an acid liquid, it'll gradually become redder and redder and redder. Then there's another chemical called bromothymol blue. What color is it when it's neutral? Kind of bluish, yellowish? But when you put it into something that's basic, what color does it turn? What color does it turn if you put it into something that's acid? Yellow. There's something called litmus. This is the most famous one. Some of you may have even heard that term. Litmus, when you put it into something that's basic, turns blue. When you put it into something that's acid, turns pinky red. Then there's something called, anybody want to try pronouncing that? Phenolphthalein. Or phenolphthalein. I think it's phenolphthalein. Do your best. I'll clue in what you're saying. It's actually colorless. It's a liquid. It's transparent. It's transparent. It's transparent. But as soon as you get on the pH scale right around 8, it turns pink. And then there's something called indigo carmine. Indigo is blue. It's one way I remember the color, but you get this chart. Indigo is carmine is normally blue, but when you get into something really, really, really basic, like bleach or oven cleaner, say, what color will it turn? Yellow. So, What color is methyl orange in a solution of pH 3? Let's see. You know what? Let's be clever. Let's put a 7 right in the middle, right here underneath there, because that's what the middle was. 8, 9, 10, 11. I'm not going to draw the lines. That kind of clutters things up. 12. Going this way, Jessica, it would be 6, 5, 4, 3. That's pretty good for now. So what color is methyl orange in a solution of pH 3.0? Methyl orange 3.0. Red. What color would it be in a pH of 3.5? Reddish, yellow. What about a pH of 4? Right about here, I think yellow and yellow. Before we do the next two, Dane, could you read that to me, please?
I quote, Mr. Dewitt, if you'd like to...
No, read carefully.
Mr. Dewitt, it would be sure to hand... Mr. Dewitt, it would sure be handy to have these on a single page lined up with a nice pH scale chart.
Instead of us flipping back and forth, it'd be nice if I'd photocopied this. So based on the chart that I just gave you, how does the color of a sample change as the pH increases from 6 to 11 when using phenolphthalein? So I'm going to scroll back up because this one is in color. Going from 6 to 11, that would be phenolphthalein from right to here. It would be this section here, yes? Okay, can you tell me how the color changes? When? Around 8? Okay, so let's say if I was describing this, I would say it turns pink at around pH level what?
8, 9.
8-ish. That's not a science word, but it'll work. Okay. If the pH level dropped below 8 again, suddenly you would see the liquid go clear again. Add some more basic material, suddenly the liquid goes pink again. If a sample turns, next question, if a sample turns blue when tested with bromothymol blue and stays colorless when treated with phenolphthalein, what's the possible pH range of this solution? Let's do the first chunk. If it turns blue when tested with bromothymol blue, so looking at your chart, bromothymol blue is this level here. When does it start to change blue? Right around a pH level of about what? Well, I think it's kind of, I'm going to say right around 8 for sure. Yeah? So let's say this. For the first section, the pH is bigger than, what did I say, 8? It stays colorless when treated with phenolphthalein. Okay, colorless when treated with, so it also stays colorless when treated with this one. I think what we're talking about is this range and that range, kind of the overlap. I think what we're talking about is sort of right in there, yeah? Somewhere between pH of 8 and 9, 7, 8, and 9-ish. And I'd take a range of answers. Yeah, ish. pH less than 9, so between pH, Mr. Dewick, you said uppercase H for pH. Do it properly. Lowercase p, uppercase H. Between pH 7 and 9-ish. So can you open your textbooks, please, to page 225? If you don't have a textbook here, someone at your table does. Make sure you can see. We're going to answer these questions together. Can I scroll up one?
Yeah. Thank you.
Page 225. At the top of the page, there is a reading check on page 225. I'm not going to rewrite the questions. We're just going to write our answers here. Number 1 says, what is the pH scale? What does the pH scale measure? What is it? Sorry? Power of hydrogen. What's that? Measured how acid or basic something is. Pardon me?
Would be acidic.
Acidic. Thank you. My English was not more gooder. Number 2. Above what pH level is a solution said to be basic or alkaline? Looking at the chart. Sarah. Above pH 7. Drinking water is pH 7. When number 3 says, when the pH rises from 10 to 12, how many times more basic has the solution become? Not 2. Yeah. 100 times more basic. No, no. You go 12, take away 10. What's 12, take away 10?
2.
It's 10 squared. 10 times 10. Not times 50, 10 times 10. Click. Come on. Number 4. What did we say for number 4? What color is litmus paper in an acidic solution? Let's go look at our chart. In an acidic solution, which is to the left, litmus paper is?
Reddish red.
Yeah, pinky red. Pinkish red. We'll play around with some actual stuff either Wednesday or Monday or next week. Some actual litmus paper. Number 5, I see an A, a B, and a C. So 5A, what color is bromothymol blue at the following pH level? pH 5. Right there. Yellow. Bromothymol blue. Make sure you're in the right one, right? B. pH 7. Blue, yellow. And pH 9, that one I got. Blue. Okay. So far, so good. Okay. We are going to pause here. Your homework is going to be a sheet. It's called pH color change. The answers are attached on the back. You probably can get it all done in class. This is also your chance to get any other missing NHI assignments done so that on Wednesday when I send this out to your parents, you can have a long weekend for free.